All right. Hello, everyone. Thanks for joining Multimodal Weekly. This is a virtual webinar series hosted by Team at 12 Labs. For those of you who are new or watch the session later on, we are early stage startup focused on building multimodal foundation models for video understanding. This is a virtual initiative that we've been doing for the past 3 years or so on a weekly basis, discussing new research in multimodal AI and foundation models, different application of customer and partners using 12 Labs in different verticals, and occasionally we have team members and our community members sharing different projects that we're building using our API platform. These are some sample session topic that we got over the past month or so. A lot of interesting project deal with our technology, ranging from education to sports to coding, marketing, e-commerce, etc. So for today's session, super excited to have three presentation group from some of our recent teams from two hackathons that we sponsored recently. Firstly, we'll have Alex Wu, James Shang, Matthew Plum, and Gabriel Andrus. They will present their project called Brick by Brick, which is a dynamic Lego generation playground that can transform your environment into buildable sets, along with providing an instruction manual composed of the Lego pieces needed and their instruction to be read. Secondly, we'll have Aryan Tapkire, Prithish Samanta, and Manav Shah. They are from NC State. They will present their project called NoirVision, which is an AI-powered forensic video analysis and credibility reporting system for crime investigator and law enforcement. And then we'll close off the webinar with Anurag Gorkar, Sumit Khilare, Shashank Walke, and Shubham Tidke. They will present their project called UNewz, which is a browser extension, acting as an intelligent overlay from YouTube. So yeah, so super excited to hear all the group today and understand the motivation for building with 12 Labs and your experience implementing it. For attendees, feel free to send your question on the Zoom chat. We have async Q&A throughout the speaking session with the speakers. So with that, I will stop sharing my screen and I'll let the first group go ahead and start presenting.
Okay, yeah, so Gabriel's going to set up the slideshow and I'll give a brief introduction when it's set up.
Okay, let me share my screen. Okay, can everyone see this?
Yes, we can see.
Okay, I'll put into present mode. Okay, so hello everybody. My name is Gabriel.
And I'm Alex, and unfortunately, James and Matthew could not join us, but we'll be presenting.
Okay, so this is our project, Brick by Brick, built for U of T Hacks 13. So the theme for U of T Hacks 13, just to give a quick overview, was identity. When our group was talking and thinking about identity, we identified that memories are a core component of our identity. And so, we got to talking even more about, why we're in computer science and why we like to build things and really why we're here. And we all identified that our journey as builders started with Legos and building Legos. So we wanted to build something related to that theme.
Yeah, and more so, we were inspired because they gave us a mascot of their Lego piece. It's missing its antlers, but yeah, it's really cute. So we were like, let's build it. So anyways,
Okay, so our idea, as James already said, Brick by Brick is a Lego generation playground, and the gist is, it lets you upload a video or a photo, and turns the video and the photo into an interactable 3D Lego set, and will also provide you with instructions on how to build the Lego set and a list of pieces in case you actually want to go out and build what we've generated for you.
so the tech stack we went with is obviously 12 Labs. We had Gemini and Backboard.io Orchestrator and also Solana DevNet. And yeah, so how this actually works is we need, in order to build it in Lego, we need volumetric context, which is just basically like you can't just know what's in your video. You actually need to know how they interact with their surroundings. If I had a desk and my computer, I can't say, oh, I have a computer, I have a desk. I need to say, oh, the desk is a meter off the ground, the computer is centered, and blah, blah, blah. So by using the Pegasus model to extract this rich semantic metadata, we captured the spatial logic required for complex builds. And simultaneously, we had Morango providing a searchable index of visual features to verify dimensions and get different angles of our main features in the video. So this digital blueprint is then passed to our what we call our voxelation platform, where we first use Gemini to create a simple 3JS representation to simplify the 3D environment to make it a bit easier to handle for the next upcoming steps, like Backboard.io orchestrator. And Backboard then converts the space into a discrete pixel art form, which is essentially what you would see if you played Minecraft, you build something in Minecraft. And using their over 2,000 individual models, we task it to use using our custom formula of like curvature and size. So something that's maybe a complex curvy item like a lamp on your desk would be sent to something like Opus Claude, while something as simple as like a rectangular desk could be Gemini 1.5 Flash. Finally, we have a Gemini agent that applies a simple greedy optimization formula we created while fetching data from the Rebrickable database, which is just a database of all the Lego pieces in existence. And we select the right bricks, we have our voxelization 3D pixel art model, and we pick out the right bricks, put it in there, and we build it from the ground up. So then we also have an instruction manual that gets created. And to really emphasize on the memory aspect, we created it, we connected it to the Solana DevNet. We had our own brick coin, which essentially links the user to the Lego shop and has all the Lego pieces already set in. So now they have a memory to remember their Lego build, but also an easy way to just buy the Lego piece. So now we're going to show our demo video we presented for the hackathon. And yeah.
Yeah. Okay, so as Alex just mentioned, here's the demo video, so you can see kind of what we're talking about. And I'll leave Alex to comment.
Yeah, so here's our UI. We might skip a bit of it since there's a lot of loading time, but essentially, yeah, maybe skip to the part where it's a bit of action.
Okay, so we have the front end, and then yeah, here you see, you can upload a video from your computer. This video is actually my room or my dorm room. Uh, I'd like to draw your attention. Okay, see my books. Winnie the Pooh right there. Uh, Pay attention to that.
Oh, but yeah,
Process the video.
Mhm. Skip this part because it definitely takes a while because of the amount of stuff we use. And yeah, so here is what our Gemini creates a 3D model of the view to just dumb it down for the next step. And we have the picture of the final 3D model, but it's not on this video. Gabriel, do you think you can get it to show them, or is that I
That's
can just
probably
talk
a
about
bit
some other stuff.
difficult.
Okay, but anyways, we had a 3D model. We have it, but oh, here's the instruction set too. But we really had to like dumb a lot of it down because it was just a lot of AI usage, a lot of token usage, and which leads into the problems we faced. Next slide. Yeah. I think we can skip this part. Let's go to the next.
Yeah, one sec. Okay, challenges.
But yeah, the challenges, as mentioned, it was really inefficient. And since it's a hackathon project, there's a lot of things to be optimized, especially if you're using so many AI agents. So that was the biggest challenge we had to face while like juggling between how much credit we were given. And also the greedy algorithm was really a pain. Originally, our project was just directly getting one by one pieces and filling up the voxelization grid. And that if you use Lego, you know that's like not great because you want the Lego pieces to be connecting with each other. You want bigger pieces. And also, yeah, so that's basically it. And the Gemini feature is connected to that, is finding the right pieces is our biggest challenge.
Yeah. Okay, so lastly, I'll talk about some next steps. Where we want to go further with this project. So as Alex just mentioned, and as you saw in the demo video, we use a lot of agents, and it is very expensive, to take in the whole scene of the video and construct a model from that. So instead, we want to use 12 labs to analyze the video, tell a story, and then from that story, we want to let the user select a certain item in the video. For example, Winnie the Pooh, that best encapsulates that video, that memory, and then we want to construct the Lego for that instead of the whole scene, just to make it faster. Additionally, we also want to fetch from the LDRAW database. So currently we use the rubricable database, but the difference is that LDRAW lets users upload their own builds. So we have a lot more room for creativity and parts that may not be in the rubricable database. So that's the end of our presentation. Thank you. How about Shams?
Awesome. Thanks, guy. I guess two quick questions from my end before we move to the next speakers. Number one is any feedback for 12 labs just from your experience using our models. And number two, can you maybe explain more that 3D algorithms implementation? How does it work, and why is it difficult to scale?
Sure, I can take the first question if Alex, you want to take the second. Feedback for 12 labs. I don't know. We had a lot of fun building with 12 labs. I think like the documentation was really easy to navigate. It was fairly straightforward. 12 labs actually simplified a lot of the more complicated points of our video, so of our project. 12 labs is honestly like the simplest part. So I don't really have any feedback except for good job.
Yeah, I totally agree with him. It was like really easy. You can see your videos clearly. You even have sample videos. But on to the second question. Are you more interested in like the what I was just explaining, or was there a specific part you were a bit maybe you want more explanation on?
I think I just missed your early explanation of the greedy algorithms, like the pseudocode part. Maybe you can just walk it over and explaining why it is difficult and computationally expensive.
Okay, yeah. So one thing I forgot to mention was that Lego comes in a lot of custom Lego pieces. There's curvy pieces. There maybe is like a Lego object. So we wanted to create, simple it down just to get it working. We used only like bricks, essentially like rectangular prisms. So our greedy algorithm was essential for the project because, as I mentioned, if you just have one by one pieces, they'll never actually be able to connect with each other. So our greedy algorithm was essentially, oh, we have a 4 by 8 part here. We just want to grab the biggest object available that would fit in here and fill in the gaps later. So to keep it simple, yeah, just whatever is present, we just grab the biggest object we can find from the database.
Great. Yeah, thanks, Alex, for looking over it. And yeah, I think like seeing how like collapse become a specific video analysis agent in the broader workflow. I think it's also kind of the common workflow that I saw the developers really clear to the user. It was great to see like how you showcase how the entire workflow look like. With that, let's move on to the second speaker, presentation. So Prithish, Aryan, and Manav, do you guys wanna go ahead and present?
Yeah. Hi, James. I'll present the screen for the entire team. Is my screen visible?
Yeah, we can see.
Mm-hmm. Yeah, just a minute. Yeah, so hey guys, I'm Aryan. I'm here with my teammates Prithish and Manav, and we're going to present our project NoirVision, which is an AI-powered forensic video verification system. We built this project for our hackathon at NC State University. So the basic premise that we took, which led us to make this project, is as follows. Imagine you're a professor at a college. Okay. A clip goes viral, a 30-second clip, where it shows that you shoved a student out of the classroom. Now, the university takes action against you. There are all sorts of threats on you, and all of a sudden, you find yourself in the middle of an academic abuse. Now, that's not good for you, right? Turns out that is not the entire picture. The real reason was that the student tried to attack you and you were acting purely out of self-defense, and that's why you pushed them out. And you were the one who called for the security on the campus, not the student. But nobody cares about that because this was just a small 30-second clip they tried to make viral out of the entire 40-minute video, which nobody tried or cared to go through. So that is our entire premise. Now, usually, whenever an investigator tries to go through their entire set of manuscripts they have for investigation, their process looks as follows. So they have like about 4 to 6 hours of CCTV footage to analyze, and that takes hours and hours of manual and tedious labor to go through all of it, which is subjective, entirely exhaustive, and it also takes away their precious time, which they could have used for better judgments and better investigation practices. NoirVision comes into play because it helps you to analyze all of that entire video footage in just 30 to 60 seconds on average, gives you objective API abstractions, and gives you an automated standardized reports with confidence scores as signifying the score of uncertainty and certainties. The basic question we try to answer is, does the user's claim match the objective reality of the video footage? Because the main problem we're trying to tackle is that nowadays misinformation can often spread from fake claims based on real data, not just deep fakes. So this is the workflow we have designed for our system. In the first step, the user gets to prompt their claim and the video footage on a clean and simple React UI, which leads to the secure transfer of the video footage onto an AWS S3 bucket, which leads to the main extraction engine, which is the most pivotal and most crucial module of our entire system. We heavily depend on 12 Labs API for their multimodal models and state-of-the-art and pinpoint accurate video footage analysis. This helps us to create a textual metadata transcript from the video footage, which is in the form of events and important actions that takes place across the entire video for each and every single timestamp. This leads to the next part where we use another text-to-text LLM provided by the help of Backboard AI, which helps you to create the deductive logic and create a score of confidence for verifying or unverifying the claim. All of this is stored in our non-relational DynamoDB database. And finally, the verdict is presented in a clean and crisp manner on our UI. The reason we went through all of that is because standard LLMs cannot inherently they lack the ability to go through entire video surveillance footages because they lack deep temporal understanding of moving pixels. For this case and purpose alone, NoirVision relies entirely on 12 Labs to act as its objective observer. And this is a detailed and depth diagram of the extraction engine, which is the 12 Labs request. How it goes is as follows. The client requests with the prompt and the video footage, which hits a request on our S3 URL and uploads the raw footage directly into the pre-assigned bucket. The fast API backend, on the other hand, triggers endpoint with the S3 URL and polls for task completion, which takes about 30 to 40 seconds. And the final step is where we retrieve the comprehensive video payload, which is our textual metadata, which is then fed onto the text-to-text LLM for a detailed report. This architecture keeps the fast API backend lightweight, while 12 Labs API handles the heavy computation lifting. Now, I'd like to give it on to my teammates.
Yeah, thank you, Aryan. This is the anatomy of the extracted truth. So, what exactly does 12 Labs gives us? Like, it extracts an objective timeline of reality. As you can see, we extract precise timestamps, specific actions like two individuals talking calmly, and a handshake, objects present in the scene, and even audio transcriptions. By utilizing these multidimensional outputs, that is, the visual, temporal, and audio, we construct an airtight forensic context before any analysis even begins. Next slide. Yeah. So of course, like multi API systems are inherently fragile, and managing failures across 12 labs backboard and S3 was a major challenge. To prevent data corruption, we implemented resilient rollback logic. If the 12 lab extraction API times out or fails, our system triggers an automated protocol. It deletes the orphaned video file from S3 to prevent storage bloat, updates the workspace status to analysis failed in DynamoDB, and prompts the user to easily retry the process without having to re-upload the heavy video file. Next slide. Once we have like our factual baseline from 12 labs, we combine that objective JSON data with the user's subjective claim. For instance, like I was attacked, right? So we send both of these into the backboard API, which routes to an LLM. We deliberately choose context injection over vector-based RAG here because this is a single case Q&A, injecting the entire 12 labs timeline directly into the LLM context window, and this yields like much higher accuracy. So the LLM acts purely as a logic engine, generating a structured JSON verdict based only on what 12 labs observed. Next slide, please. Yeah, so this is like the final verdict, a 30-second credibility report visual. So the result of this prompt engineering is a structured detective style credibility report. The system categorizes the claim into one of the three buckets, that is supported, contradicted, and unverifiable. Supported in green if it aligns perfectly with the 12 labs timestamps. Contradicted in red if conflicts with the extracted actions or like the objects. And unverifiable is like gray because it's a gray area if the claim references events off camera. So the investigator is given a credibility score of 100 out of 100, like an evidence timeline and appended recommendations on how to proceed with the investigation further. Next slide, please. Yeah, so to manage these case files, we had to design an efficient database schema. We use AWS DynamoDB. Uh, Okay, so sorry, this one. Okay, looking at like the overall performance, our total per case analysis speed is just about like 55 to 60 seconds, and the processing split is roughly 30 to 40 seconds dedicated to the 12 labs extraction, and 15 to 20 seconds for the backboard analysis. The entire system is secured via AWS Cognito to make this tool like more intuitive. For law enforcement, our front end uses React and Tailwind to create a custom vintage Noir detective aesthetic with typewriter fonts for like more rapid visual scanning. And next slide, please. So I'd like to ask Prithish to continue from here.
Yeah, so as a test to test our product, what we did was we fed it a video which we got off YouTube. So the video was a 30-second clip, and it's mainly a car which was driving at night, and out of nowhere, a woman suddenly appears into the road, and the car slows down, and before it could hit the woman, the car slows down, and but the woman still acts as if she was hit, and she falls on the floor, acting as if the driver did it voluntarily. So what we did was we fed this particular clip into our product or the website, and with the clip you always have to give a claim, like saying what the person who has noted the act says happened. So what we did was we gave the clip, and we ran it two times. So the first time we gave it a positive claim, and second time we gave it a negative claim. So Arden, could you go to the next slide, please? So yeah, so this is the negative claim we gave. So we put that clip, and we put the claim that the pedestrian was crossing the road, and she had the right to do so. The car driver voluntarily tried to hit the person with the car. And so we fed this claim and the video, and we gave it for processing. After 50 seconds, we got this output. So it gave us a detailed analysis of like what happens at what timestamp. The picture is a bit hazy, but if you see closely, you can see in the second card, there's a video evidence analysis thing over there with timestamp. It says what happens. So, and it also it gives that and gives a final analysis of what it thinks happens, and it gives a credibility score. And with this claim and with the video, it gives a credibility score of rejected or less than 40%. So that's why it's rejected. Whereas if you go to the next slide, which is a positive claim which we gave, that the driver in the car doesn't want to hit the pedestrian and claims that he did try to stop the car before it could harm the pedestrian. So when we fed this for the same video, it gave a positive credibility score, which is above 60%, and it also gives the same timestamps, like what it sees versus what the claim says. It compares both of that, and then it gives the credibility score. And along with this, it also gives like how what Manav Shah said, that it also gives uh, a note of how the investigators could proceed with the investigation. So if you go, Aryan, could you please go to the next slide? So yeah, so this is what we could do in the hackathon, the 1 day hackathon we had. But this is what we also think we could expand this product to. So currently we can only give one video evidence. So for example, the video evidence we gave for testing was dash cam footage. Whereas what we could do, we could also give a dash cam footage. We could also give like a CCTV camera footage, which is from a camera on the streets, if it caught the same thing. If we could feed multiple videos and then generate an analysis, maybe it would give better scores. So that is one thing we could do, is give multi-video analysis. Second thing is we could connect it with existing video evidence management systems. We could also do market expansion, like apply this pipeline to insurance, fraud investigation, and journalism. This would help that a lot too. So in the end, I would like to say, Arun, could you please go to the next slide? In the end, I would just like to say that turning hours of manual review into seconds of AI-powered truth saves a lot of time for the investigators. You might not get like you might get like an middle, like a 50% score, but along with that, you can also get like uh, a hunch of how to proceed with the investigation further. So it saves time overall, and that helps a lot. Thank you.
Yes, awesome. Thanks, guy. Maybe one quick question from my end is, well, first of all, I think this is a very popular use case from Solaf. We do work with commercial security, you know, defense intelligence, where the use cases is you have like CCTV camera footage like this, and using our technology to those multi-view analysis, anomaly detection. So it's great that you got a chance to figure out these use cases and see kind of the capabilities in the model for that. One of the slides you mentioned was talking about like the structure output, right? That you got from our business model, objects, relationships, entities, etc. In the video. I'm curious about like the performance, like how accurate they are, any feedback from testing models to extract this by grading information from time.
Yeah, so I would like to answer that one. So we only had a day and about like 2 to 3 hours to test out the entire workflow and how 12 Labs actually converts the video into textual meta transcripts. I would say the models are like pretty state of the art, because for long videos there was only like a delay of 1 to 2 seconds at max, really, between the event and the timestamps. So the model was pretty accurate. The 12 Labs API really did its best. So yeah, that's the best we had to say about 12 Labs. I mean, again, 12 Labs was the most easiest part of integrating in the entire project.
Awesome. Let you hear that. And let's see. Yeah, no, actually, we have a new version model, the Pegasus model coming up probably in the next 2 months or so, which will have improved capabilities in time-based metadata understanding. So you can even get more fine-grained, segmentation, object tracking, etc. From using that model. I saw that Kwaji got a question on the chat. Maybe you can answer that one. How would you deal with claim contradiction that are in mixed chronological order? Anyone from your team want to take it?
Yeah,
Sorry.
sure, I can take that. So like the claim contradictions that are in mixed chronological order. So like the video, right, which we have, that is actually our source of truth, right? So anything like that is contradicting to the video's transcript and whatever information we get from the video will be like marked as something that is not true. And like even if the claims can be in mixed chronological order, because yes, an incident happens, but not always a person can remember and tell everything in chronological order. However, like the truth of the claim is what is being checked, and that has to be true. So that is handled.
Awesome.
To that, I would like to add that, like what he said was that it may not be that what a person is saying is always chronologically correct because a person can forget. But right now, we are not assuming that the claim is correct or wrong. We are just checking whether the footage we have which we got from a CCTV camera. Our only assumption is that the footage we got might be from a trusted source like a CCTV camera or like a dash cam, which we showed right now. If that footage, if the contents we get from that is matching the claim that was given to us, so it can be that the claim given to us was chronologically not correct, but we're just checking whether the contents of the claim and the contents of the footage matches or not.
Awesome. Yeah. Thanks, British, for the detailed explanation. You're dealing with that logic of, writing the algorithms from the RLM and then the VLM from the side. This is quite interesting so that you can get a qualified report and answer out of it. Awesome. So we got roughly more than 10 minutes left for the webinar. So let's have the final presentation group coming in. So Anurag and Shubham, the rest of the team, you guys want to go
Hi,
ahead?
James. Shubham here. I'll share my screen. Yeah.
Yeah, hi. So I'll start with the presentation. So, hi everyone. Thank you, James and 12 Labs for this opportunity. And today we'll present our project that was UNewz. Our project was developed at the Hack NC State hackathon that was conducted. And our mission was basically to bring transparency and like diverse perspectives back to the way we consume news on YouTube. And we have integrated 12 Labs video intelligence to help users navigate like the vast landscape of media, which is often dominated by sensationalism and algorithmic bias nowadays. So the basic motivation behind our project was YouTube has fundamentally changed the way we consume information nowadays, and it has become a primary global news source for many people. However, there is a major issue with this. So the current algorithms, those are designed for like engagement more than accuracy. So it traps users in like echo chambers and bubbles that so that they get only information that is catered to their particular views. Then this combined with like the rise in clickbaity and AI generated content is rapidly eroding like the public trust in digital media. So our core idea was why not audit YouTube news? So we wanted to build a tool that could compare a video's thumbnail against the actual content and also analyze how users are engaging with the video content by looking at the comments that are under that video and the like to dislike ratio and everything. So we'll just look at a overview of the pipeline of our project. So first, we used like a Python script in order to download the actual YouTube video and the metadata associated with it, like the comments and the like dislike ratios and everything. Next, once we have fed that video to 12 labs, we get like a unique video ID after the analysis of the video is done. We use this video ID in order to store our analysis part that we do further in order to have a faster like extraction the next time a person visits the same video. Then this is the third part is where we utilized our 12 labs APIs. So that was basically for the transcript and the comment summarization. Then we also use Gemini to analyze the comments in order to see how well people are engaging with the content. Are they positively engaging, or there are any counterpoints that are mentioned in the comments or not? And in order to ground our analysis in the basic truth, uh, so that we are not just looking at what was presented in the video, we also used the DuckDuckGo search engine to generate relevant search queries and look at actual news data that was around the topic that was covered in the video. The next slide, please. So next we'll move on to the core part of the video analysis pipeline. That was how did we use 12 Labs Marengo model. So once we have extracted the raw file from YouTube, we utilized your task API in order to upload it directly to the cloud and retrieve the video ID, which serves as the key to our content. And what makes Marengo essential for our platform was the native multimodal embedding capability. And by leveraging the temporal segmentation, our extension can understand the video's logic, basically scene by scene representation of what was being depicted in the video, and which is far more accurate than just looking at the video transcript or the captions of a particular video. And by storing this analysis in like a cache-based key value store like Valkey, we can retrieve this information faster for further use. Next slide, please. Yeah. So once our video is indexed, we move on to from like the perceptive to cognitive reasoning using the Pegasus model provided by 12 Labs. We do majorly two things. First one is the deep summarization. We used Pegasus's long form video understanding in order to generate a ground truth for the video. And we feed the Marengo embeddings with our own prompt. And then we try to give a visual description of the thumbnail for that particular video. In order to get this description, we use Salesforce's blip model. And we just compare whether the contents within the thumbnail match what was delivered inside the video to get like to analyze whether this video thumbnail was a clickbait or not. And then we also do a audit and credibility assessment. This is where we actually audit the news, right? So we provide Pegasus with the creators YouTube metadata, like what was the title of that video, what are the different what was mentioned in the description, what are the tags added by the creator. And we also do a summarization of the content, and all of this data along with the video metadata. We basically do like a zero-shot audit against the audio, visual, and the textual content. And by comparing the creator's claims versus the visual proof, we calculate the following scores for misinformation, credibility, and clickbait. And finally, we have a front end where we are just presenting all of this information in a easy format for the viewer to consume so that they can get a analysis of the entire video in a single view. So yeah, now we'll move on to the demonstration of our project. Shubham, welcome.
Yes, so I'll show you a demonstration how our browser extension works. So whenever you go on a YouTube video, you can see that the extension pops up and give you a button to analyze the video. And once you click analysis, it will generate a summary about the video and all the metrics which Anurag discussed. Now, because the results were cached, it fetched all these details very fast. Otherwise, it takes a minute or so to analyze the video. And as you can see, first we show the user what are the high-level tags for the video. Like this video talks about technology, has politics in it, and is also quite opinionated. Now, secondly, by using the 12 Labs API, we get a quick summary of the video, and this helps the user understand what the video is about. Like here, you can see it clearly says it's a satirical and exaggerated portrayal. So the user has a better understanding of what they're getting into from this video. And secondly, by matching the thumbnail and the actual video, we get what is the clickbait meter for this video. A high meter basically means the video does not portray what's shown in the clickbait. And we also have a credibility score, which tells the user about what the facts and statements made in the video, how credible are those. And for verifying that, we first extract these facts by prompting 12 Labs API about the video, and then we use DuckDuckGo search engine to search all these facts online and then compare if there are any articles or resources present against these facts. And from the metadata present in YouTube regarding the comments, we basically use Gemini to analyze the comments about this is basically the sentiment analysis of the comment section, positive, neutral, and negative comments. And then these are the fact-checking results which the user can see. So here it mentions all the claims that were made in the video, which of them were true, which of them were false, and then also the search results from where you can check these claims. I'll scroll down. Sorry. Yeah. Then these are the key insights from the video, which is basically again similar to summary, but it talks about what segments the video is divided into and what each of these segments talk about. And now to make sure that the user is not trapped in a bubble of a particular opinions or a particular thought process, we also provide alternate perspectives related to this topic, and also sources where the user can view this. And these are all the clickable links. For example, if user can simply click here and go to an article which talks about which also discusses the same topic but has a different opinion about it. And finally, we also show the political bias in this video, how left-leaning, right-leaning, or neutral the video is. And finally, we show community insights and the community vibe. The community vibe is basically how the comment sections is reacting to the video, and this is a quick summary of what's happening in the comment section. And community insights is what the high level tag of what what people think in the comment section about this. If they think so, here they think this is a very the highly controversial video, and what is the dominant topic. So yeah, that was all from my end.
Yeah. So that was our project. Thank you.
Awesome. These are pretty interesting species, I'd say. I think a while back, my team was trying to do a Chrome extension, similar idea like this, that can like open into YouTube. Yeah. Automatically get summaries from YouTube content. And I think your ideas is even more advanced than that, which is actually fact check the quality and QA of the content itself. It's very cool. I guess just a high level question is throughout the implementation, which part of the workflow seemed to be like most technically challenging, and how did you resolve it?
Yeah. Shubham, can you take that question?
Okay, so I think the video and the downloading those videos and analyzing them. So that was, I would not say it was challenging. I would say it was very time consuming initially, because for every videos, even I think the 12 labs was actually, we found out that it was quicker to get an analysis from there compared to downloading the video. So what we thought of doing is why not then cache all these because even though the videos are big, we don't need to actually cache those videos. We actually just need what the metadata, that what the analysis is after processing the video. So then we came up with the idea of basically using a cloud cache, which is Vultr, and then storing all this metadata for all previously pre-processed videos. So like how I show you in the demo, once the video, as the video is already pre-processed, the users could very quickly get the analysis, and it also saves a lot of computational cost, which would get wasted if we keep processing the same videos again and again. So I think performance was the main challenge we faced.
Awesome. Yeah. No. That make total sense. Yeah, like similar same question. Like I asked the other team and each high level feedback in terms of performance of Maranko and Places for your specific use cases. So it's because I saw that like the way you use Places is a bit more nuanced, right? Just creating the ground truth from the video. So deep reasoning, automatic information extraction. So how was the result from Places from objective?
Yeah, so actually, as Shubham mentioned, just a minute, there was one echo. Yeah. So just for the first download, it was slow, but once we have that video uploaded, the uploading was fast to the 12 labs as well as the querying. We were using the API to give the structured prompt, and the answers were like fast as well as accurate that we were expecting. So at first we thought that for the larger videos it would take time, but it didn't significantly increase time as well. So even for the 30-minute video, 35-minute videos as well, we were getting responses that were fast for once that video was video that was processed by the 12 labs. One thing is like if we switch too quickly in the YouTube, there was rate limiting on 12 labs, but it is expected. But rather than that, it was good.
Awesome.
One more thing which I would like to say is we also tried out splitting the video into 10 minutes chunks instead of putting the entire video at once. So it was a bit faster than doing the entire video and then combining those results, and even the performance, which is basically the output was also not very varied by splitting it, which you would think them output might become, basically the analysis might worsen by splitting the video, but we found that it stayed almost the same. So that was one thing we tried.
Yeah, no, I think that's good to know. It really depends on your use cases. I think for long form video, right? Like, if you ask question that require understanding the entire long form video, then long video uploading, long video analysis will make sense. But if your goal is for like, like segment level understanding, scene level analysis, then that approach of chunk the video down into smaller segment and then cause how analyze API for that to get the answer can also work. But I would say, like, as I explained, as I mentioned with the previous group, like our newest version, Pegasus 1.5 will have a very, very good capabilities in terms of segmentation, time-based metadata. So even if it's like a very long form video, it should still be able to answer very, very specific and nuanced detail that correspond to a timestamp, right? So that basically remove the effort to break the video down into segment, right? Yeah. So there's just one note on that, because a lot of our customer use cases is like like raw footage that is long form, and they just need to deal with that footage, right, without having the capabilities to break that down into segment. Because once you break it down into segment, you have to choose like the length of each segment, the transition between each segment, right? Yeah.
So is there any special handling which you guys do while transitioning between segments so that maybe it's more smoother?
No, not this. Not any specific like logic. It's just a training data and the model performance, right? So
Okay.
we train our model in a way that it just handle like segment level scene analysis better. So like in the training the base model, it will become better. So that require a lot of different things, from like better data collection, data labeling, but also actually better algorithms that power the video foundation models.
Okay, I see.
Awesome. Maybe I saw that Wahid got the last question here. Maybe if you can just answer this one, and then we can close off the webinar.
Yeah. So as our final output, which we showed on the extension, is mostly text-based or summary related. So what we do is, once we get some information for a specific segment, we just combine the text and then even more try to condense it even further for summaries. And for fact checks, we don't worry a lot about combining the segment, because we are just getting a high level whatever statements were made in the video based on timestamps. So it does not involve combining any segments. So yeah, apart from the summary, I didn't think we did any special handling for the segments.
Awesome. All right. Great. So I think that should be it for the last group. Thanks again for presenting. Yeah, very, very interesting use cases to demonstrate a unique workflow using the Taurus model. So yeah, thanks everyone for joining today. Like all three presentation, tackle, very three separate and different workflows, right? So I think it's interesting to see how our model is quite versatile and does a good job at the different objective, right? That the developers want to do. So yeah, I'm always interested in how startup developers community using the models and kind of use cases that they can deal with it. So the recording of this webinar should be available on YouTube at some point next week. So I'll be sure to share that with all the presenters, and so you can share with your friends and social, etc. We run the series on a weekly basis. So if you found this content to be interesting, we'd love to have you come back and join a future session. And for the attendees, yeah, thanks for asking a great question and supporting us with time. All right, thanks everyone, and hope you enjoy the rest of your Friday. Cheers.
Okay, thanks a lot for this opportunity.
Thank you.
Thank
Bye-bye.
you.